Hi friends, I hope you guys are doing well. In this video, we're gonna talk about solids of revolution revolving around horizontal lines above the x-axis. So let's take a look at this problem. Find the volume of a solid that results from rotating the area between y is equal to x, that's gonna be the pink line, and y is gonna be equal to x squared, that's the blue function, around the line y is equal to 2. So if you take the area between these two curves and you rotate it around that horizontal line, what kind of three-dimensional object are we gonna get? Well, we're gonna get something like this. So as you can see, our three-dimensional object is gonna look something like this, and we wanna find the volume of this three-dimensional solid. So the volume of this solid is the same as the volume of the outside function, so the volume of the outside function minus the volume of the inner function. And if you remember from my previous video, the formula to find the volume is just the integral from a to b. So the integral from a to b, and in this case, it's from 0 to 1. So that's going to be 0, this is going to be 1 of a of x dx. It is the same over here, so that's going to be the integral from 0 to 1 of a of x dx. So what is a of x? Well, a of x is the area of the cross section, which is a circle. So let's write it out. The area of a circle is the same as pi times the radius to the power of 2. And we need to write the radius in terms of x. So this is equal to pi times the radius. And if you look at the diagram, you can see that the radius is from here to here. So how do we find the radius? Well, you know that the distance from here to here is 2. That's 2, because that's y is equal to 2. So the distance is 2. And the distance from here to here is x squared. So the distance in between has to be 2 minus x squared. Pi times 2 minus x to the power of 2 to the power of 2 again. So basically, you just take the top y and you minus the bottom y, and that's always going to give you the radius in between. Now, the next step is to put this back into our integral. How about the area of the pink cross section? Well, again, it is just a circle, so the area is just pi times the radius to the power of 2. And we're gonna rewrite the radius in terms of x. So this is gonna be pi times the distance in between. You take the top y minus the bottom y. That's gonna give you 2 minus x. So this is gonna be 2 minus x. And don't forget the power of 2 on the top, because that's the radius squared. So let's rewrite this integral in terms of x. So solving these two integrals will basically give you the volume of this solid. So let's go ahead and do that. And as you can see, since both of them have the same boundaries, we can just mash them together into one integral, and that's gonna simplify a lot of things. So this is equal to the integral from 0 to 1 of pi times 2 minus x to the power of 2 to the power of 2 and minus whatever is over there. So minus pi times 2 minus x to the power of 2 dx. And the next step is to factor out the pi. So this is equal to pi times the integral from 0 to 1 of 2 minus x to the power of 2 to the power of 2 and minus 2 minus x to the power of 2 dx. So what we need to do is solve for this right here. So 2 minus x squared to the power of 2 is the same as 2 minus x squared times itself. And don't forget the rules. You have to take this, multiply by this, take this, multiply by that, and the same thing for the other term. So let's go ahead and solve it. 2 times 2 is going to give you 4. 2 times negative x squared is gonna give you negative 2x squared. It's the same thing here, so minus 2x squared. And this times that is gonna give you positive x to the power of 4. And we can rewrite this as x to the power of 4 minus 4x to the power of 2 plus 4. And let's go ahead and put this back into our integral. Now minus 2 minus x to the power of 2 dx. So the next step is to solve for this right here. Let's do blue this time. So we have 2 minus x times itself, so 2 minus x. Now 2 times 2 is going to give you 4. 2 times negative x is negative 2x. Negative x times 2 is negative 2x. And negative x times negative x is positive x to the power of 2. And this is the same as x to the power of 2 minus 4x plus 4. So let's put this back into our integral. And we are almost done. I'm going to rewrite this. This is going to be pi times the integral from 0 to 1. We have x to the power of 4 minus 4x to the power of 2 plus 4 and minus negative x to the power of 2 plus 4x and minus 4 dx. So this is again equal to pi times 0 to 1, x to the power of 4, and negative 4x squared minus x squared is going to give you negative 5x squared, and 4 minus 4 is just 0, so the last thing we have is just this one, so plus 4x dx. And time to integrate this integral. This is going to be the same as pi times the antiderivative of x to the power of 4, which is just 1 over 5 x to the power of 5. The antiderivative of negative 5x squared is negative 5 over 3 x to the power of 3. And lastly, the antiderivative of 4x is just 4 times x to the power of 2 over 2, which is just 2 times x squared. And the boundary goes from 1 to 0. So again, this is the same as pi times 1 over 5 minus 5 over 3 plus 2. So that's after plugging in these variables. And it's just a matter of solving these fractions now. So this is the same as pi times 3 over 15 minus, this is going to be 15, that's going to be 25, plus 30 over 15. So 30 minus 25 is positive 5, and positive 5 plus 3 is 8. So the final answer should be pi times 8 over 15. And one final step, this is just the same as 8 times pi over 15. And this right here, so this right here is the volume of our solid of revolution.